Hey guys, Mr. Gucci here to finish up Unit 9 review by doing these last two questions from the review. Our percent composition problem and an empirical formula problem, which is just the percent composition problem going in reverse. I can tell you that your final exam is going to have problems that are similar to both of these. So this is something that you need to be ready to do. All right, so we're going to do both of these questions now. Starting with number 11, what is the percent composition of the elements in ammonium carbonate? All right, so let's get to it. I'm going to make a new page here. Let's see here, insert blank page. All right, here we go. So let's get going. All right, number 11, ammonium carbonate, not aluminum carbonate, ammonium carbonate. So the first step is you got to figure out what the formula of this stuff is. If you go to the common ions, you will see that ammonium is actually a polyatomic ion, NH4 with a 1 plus charge. And carbonate is CO3 with a 2 minus charge. So let's get to it. NH4 with a 1 plus charge and carbonate, CO3 with a 2 minus charge. When I crisscross them, I get the formula NH4 2 CO3. That is ammonium carbonate. So we have to figure out what the percent composition of all the elements are in this by mass. So what percent of this substance is nitrogen? What percent is hydrogen? What percent is carbon? And what percent is oxygen? So to figure out the percentage of nitrogen in this, that's going to be equal to the mass of all of the nitrogens, divided by the total mass of the thing. And that's the same for any percentage ever. It's always the part divided by the whole. So let's see here. How many nitrogens do we have in this compound? Well, NH4 has 1 nitrogen, but we've got 2 NH4. So that's a total of 2 total nitrogens in this compound. So 2 nitrogens divided by the total mass. Now this is going to be a little bit of work here, folks. All right. So the top of this fraction is 2 nitrogens. On the bottom is 2 nitrogens plus, let's see here, 4 hydrogens times 2, that's 8 hydrogens, plus the mass of a carbon, plus the mass of 3 oxygens. So let's work this out. All right. So clear some space here a little bit. There we go. So nitrogen is 14.01 grams per mole. I found that on the periodic table. So 2 times 14.01, that goes on top. And on the bottom, you have, you know what? I'm going to move this to a new line. There's just not enough room here, all right? And that's okay, guys. You're going to have all the time and space you need to get this done. So on the top is 2 times 14.01. And on the bottom is 2 times 14.01 plus 8 times hydrogen, that's 1.008, plus carbon, that's 12.01. I know these. You would look them up on the periodic table, plus 3 oxygens. So the top is going to be 28.02, that's 2 times 14.01, and the bottom is, I'm going to need a calculator, is what I'm going to need. Let's see here. So 28.02 plus 8 times 1.008, that's the hydrogens, plus 12.02 plus 3 times 16. The bottom of this is 96.104. Okay, so let me pause this just to double check. Yeah, we good. All right. So, where was I? Okay, yes. So, here we go. The percentage of nitrogen in this compound is 28.02. That's the mass of all the nitrogens on top, divided by the total mass of the whole thing, 96.104. The percent of nitrogen in this compound is 0.292, which is equal to 29.2%. All right, that's the percentage of nitrogen. Let's find the percentage of hydrogen. Now, the hardest one is the first one. After that, it gets a lot easier. So let's take a look and see why that is. Okay, so the percentage of hydrogen is going to be equal to the mass of the 8 hydrogens in this compound divided by the mass of the entire thing. Now, here's where you start to save some time. You don't need to add together 2 nitrogens and 8 hydrogens and a carbon and 3 oxygens again. You already did it once. So you can just use that same number for the rest of your calculation. So this is the mass of 8 hydrogens, or 8 times 1.008, divided by 96.104. Let me do this. 8 times 1.008 divided by 96.104, and you get 0.0839, which is 8.39%, right? Bounds that decimal place over twice. It's 8.39% hydrogen. What else? We've got carbon. What percentage of this thing is carbon? This is going to be even easier, all right, because there's only one carbon, all right, and you're dividing by the total mass of the entire compound, 96.104. Where did that 96.104 come from, Mr. Gucci? Well, I added together 2 nitrogens plus 8 hydrogens plus a carbon and 3 oxygens, and I got 96.104. I don't need to do that again. I added them all together once. I'm going to need it for every step of this problem, but I don't have to add it together again. I can just use it. It doesn't change. All right, so here we go. 12.01 divided by 96.104. 12.01 divided by 96.104. And I got, let's see here, 0.125, which is equal to 12.5%. So this is 12.5% carbon. The last substance in here is, what percentage of this is oxygen? Well, this has 3 oxygens divided by the total mass, 96.104. So that's 3 times 16, that's the molar mass of oxygen, 16.00, divided by 96.104. So 3 times 16 divided by 96.104. And I get 0.499, or 49.9%. Okay, there we go. That is the percent breakdown of all the elements that make up ammonium carbonate. Now, the way you can check your answer is by adding all of the percents together. If they're pretty close to 100, then you got it right. So 29.2 plus 8.39, all right, plus 12.5 plus 49.9. Okay, and when I add these all together, I get 99.99%. And you know what? That's probably good enough. All right. You don't need to get exactly 100. This is more than good enough. So there you go. So that's the percentage breakdown of all of the elements that make up ammonium carbonate. All right. Now on to the last problem for this chapter. Insert a blank page. All right. when I upload this, it's going to be kind of out of order. I don't know why it does what it does. All right, the last question, which is, we'll go here and double check here. What is the empirical formula of a substance that is 25.9% nitrogen and 74.1% oxygen? All right, so this is basically doing percent composition in reverse. So 25.9% nitrogen and 74.1% oxygen. So from this percentage, we got to get back to a formula, all right, which is the opposite of the percent composition where you had a formula and you had to get to the percentage breakdown. So the way we do this is through several steps, and you're going to want to set it up, whether it's 2 substances or 3 substances. You want to set them up in columns going down the page. All right, now the first step is this. The first step is we got to get these percentages into real world amounts. And the way we do that is just pretend you have 100 grams of this stuff. Just pretend. And so 25.9% of 100 grams is 25.9 grams of nitrogen. And 74.1% oxygen would be 74.1 grams of oxygen. The fact is that I'm just pretending 100 because that makes the math easy. I just get the same number as the percent, but it's a gram. It would work with any number. If I pretended I had 50 grams and then did the percentages, or 20 or 1,000, in the end of the day, the math would all work. All right, so that's the first step. Get these guys into grams. The next step is turn these grams into moles. All right, convert from grams into moles. So to do that, 25.9 grams. All right, to go from grams to moles, we divide. So 1 mole is how many grams of nitrogen? 14.01. So 25.9 divided by 14.01, we have 1.85 moles of nitrogen. Now on the oxygen side here, we're doing the same thing, 74.1 grams of oxygen. We want to get out of grams into moles, and oxygen is 16 grams per mole. So 74.1 divided by 16. And I get 4.63 moles of oxygen. All right, what's the next step? The next step is divide by smallest number. So the smallest number between these two is 1.85. So divide them both by 1.85. This is just simplifying the mole ratio. 1.85 divided by 1.85 is 1 mole of nitrogen. 4.63 divided by 1.85 is 2.5 moles of oxygen. At this point, you might be like, oh, I see. I got some simple whole number ratios. Well, almost whole numbers. 2.5 is not a whole number. Fortunately, we can multiply everything by 2 to make it a whole number. So we've got 2 moles of nitrogen for every 5 moles of oxygen. So the empirical formula is, if you got 2 nitrogens for every 5 oxygens, it's N2O5. That is the empirical formula. Now, empirical formula means this isn't necessarily the real formula. It's just the smallest ratio formula. So this substance that is, going back to the top here, 25.9% nitrogen and 74.1% oxygen, that could be N2O5. That could also be N4O10. That would have the same percentage breakdown. Or N6O15. or N8O20. All these guys would have the same percentage breakdown because the ratios are the same. So if we only have the percentage breakdown, then all we can do is say this is the lowest ratio or empirical formula. That's all we can say. All right. And there we go, guys. That's the end of review for chapter 9. Feel free to stop by and work with me if you have any questions about any of this stuff.